Getting there in the end. Right, hello and welcome to the Patreon-only live broadcast on today, the 13th of May, 2018, and not 2008 as I've written there. Thanks to all patrons, new and old. I'm not sure how many new patrons there are this month. A few left and a few new have joined, which is always the way. But there we go. Yeah, it's pretty good, and obviously that's how the projects get built mostly, or at least it means reliable cash flow for the project. So, yeah, much appreciated as always. So don't forget to open the link in a new window on a new tab so that you can see the chat. There's a few people in there already. If everything goes wrong, let me know. The live streams have been pretty reliable most recently. Sometimes in the past, they used to just disconnect or if I disappear. And I'll be looking out for questions during the live stream. And at the end, there's normally some time for other stuff. So there we go. Yes, that was the Bat Boots, which we'll talk a little bit more about. Well, I might as well talk about them now, really. Yes, so Bat Boots indeed. So obviously this project is sponsored by Ninja Tech. So it's not built to patrons. There's 2 more videos to go pretty much. But that is one of my Bat Boots with those. I posted a mirror selfie for patrons, but that's the back there. There's a lot of Velcro in there that holds it all on. And obviously it's mounted on a normal boot. So that video is in the process of being finished. There are thigh pieces as well, which look like this. Go that side. Which I've got kind of a scoop cut out in, and I've basically done the same thing I did with the forearms with the armadillo rigid piece and the cheetah piece bent over, which has got slots cut in so it bends round, and there's a recess there with bolt holes to fit in a future bat gadget on each thigh. So yeah, that's pretty much it for that video. It was quite a lot of printing, obviously, to make all of those, both boots and both thighs, and all the strapping, and then it takes me about half an hour to get into it to demo the whole suit. But I'm quite happy it's coming together, actually. It's a bit daunting to start with. There's obviously things we'll go back and tune up, but I'm probably going to bring those into a series when I bring the Bat board back, and we'll kind of have an ongoing Bat series rather than specific projects, where a bit of the suit, a bit of the board, maybe some other Bat gadgets will get worked in, and it'll be like an ongoing Bat series. But that's probably for the future. I can't fix the Bat board up till I've learned to weld, which is another thing that has to happen. And we'll be talking a bit more about my workshop space as well, and the CNC, and everything's getting serious with metal. I was a bit inspired by Colin, obviously, so having worked on Hulkbuster with him, he's got quite a nice shed and lots of tools. So that's what's going on there. Yeah, the CNC was actually just given to me. I couldn't really refuse. It's massive. They wanted to give me, I think, an 8x4 foot. Basically, Bob from I Like to Make Stuff took the 8x4, which is coming up in his channel shortly. I can't fit that in my house. Yeah, so the 2x2 is big enough. I thought it would be much smaller because 2x2 is not very big. But it's ginormous and it's really heavy duty. I still haven't cut anything. So I'm taking my time to learn CNC before making videos where people shout at the screen, apart from the pronunciation of router. So, yes, I posted yesterday. Hello, everyone joining. I can see more people joining in the chat. Yes, I mentioned in a post yesterday about some things I was going to talk about. So one of those is the Open Dog project, which I'll come on to. The first one was about building Hulkbuster with Colin Furze, which there's a few questions and things floating around. So yes, just under a metric ton, we think. It can't be moved in one piece unless you pick it up with a telehandler, which is a bit awkward because you can't get it out of places like back gardens. So it all comes to pieces, and at the beginning of the final video, you could see us taking it in out of a van. The legs each can't be lifted by humans. 4 people still can't pick them up because they're so heavy. So they have to be rolled on like steel bars and on trolleys and things to try and get them into places, and then slid on sheets of steel to get them onto the frame where they're bolted down. The body is about a 4-man lift with big steel poles that go through, and 4 people have to carry it. And that doesn't include the front chest plate. And then the arms are probably a 3-man lift each. So it's pretty heavy and pretty powerful. Those hydraulic cylinders have about 5 tons of crushing force. So pretty substantial. We think it costs somewhere between £15,000 and £20,000 to make. Obviously, we wouldn't have done it without eBay support. And similar to the Star Wars thing with the TIE Fighter and BB-9E, there was a sort of creative, what should we call them, agency stroke production company behind it, who obviously you can see in the final reveal in my channel with the kids' party. That's not a video that's in my style, so it was shot on proper cameras, and freelancers basically came and did the editing and things. We had quite a big say in what shots are in there. I could have made my own footage. I could have made my completely different part 3, the same as Colin made his a completely different part 3 for his series, and didn't use, or used about 5 seconds of a coconut being squashed from that video. But it's kind of awkward because I don't have Hulkbuster here to make my own part 3. So I just took that video, which wasn't as popular as the build, but there we go. So just having a quick look at the chat. MIG welding is easy. Yeah, I was thinking about doing rod TIG welding because that's what Colin does, but I'd need to decide really, and I've never tried it. I've done brazing, but we'll see. I still don't really have anywhere to do it, which I'll discuss shortly. So yeah, Hulkbuster lives now on Tom's farm. There's a guy called Tom Lamb who's in some of Colin's videos, and he's got a farm down the road with 40-foot containers where all of Colin's stuff is, all the projects. Tom Lamb's got his own YouTube channel. He was in the one where Colin blew up filing cabinets and things and washing machines with fireworks in a 40-foot container. That's Tom Lamb. He's got his own YouTube channel where he blows up toilets with fireworks and other things. Hasn't got many subscribers. And crushes rocks and knocks over walls with a forklift and stuff like that. So yeah, I've been up to Colin's during that build. It was about 8 weeks. I was up there every week pretty much, which is a 7-hour round trip. And then the final reveal, we had to take it all to, so he lives in Lincolnshire, sort of North Midlands, and we had to take it all the way down to Bristol for the shoot. So it was kind of a week out doing the shoot again. So, but there we go. We got done in the end. There was some skepticism whether it would get finished, and it did, and it was fine. So good. Yeah, so there's probably going to be some more projects with Colin. Obviously, we did the Amazon Alexa activated thing. I think Colin's still got one more video for the flamethrower to put out for that. And he's asked me to be involved in some other things, which involve controlling stuff. So I'm not sure how soon. He's got some other things he does really want to do. But no doubt there'll be 2 or 3 things a year, I think, where I get involved in his channel, which is really good because it drives loads of traffic over. Those videos obviously spike when he says, come and watch my channel. So that's really good. So let's see. Let's just answer this question. So what subscriber patron influx do you see? Not well, a few patrons, but not a large number. But yeah, about I think about 26,000 subscribers came over as a result of the Hulkbuster videos. I don't know how many came from Colin's channel and how many were YouTube recommended the videos to non-subscribers as well. So it may be just a result of that. But yeah, it did bring over quite a lot of subscribers. There's been a big spike. And obviously the views are massive compared to 10 times plus more than anything I normally get on videos. So yeah, that helps quite a lot. I think 20%, it was something like 20% came from Colin's channel and 20% or something came from 20% end cards, 20% recommended video, 20% browse features, and the rest were from some other place like my own subscribers or whatever. So yeah, it was a significant amount. And once the video does well, then YouTube starts pushing it anyway. So a lot of other people see it. It's hard to say exactly where they came from. But yeah, obviously worth doing for me. And I think Colin could have probably made it without me, but whether he could have done all the panels and got them right. And obviously we had that CAD model and that had to be approved by Marvel. So we had to keep sending them pictures. because they didn't want us to misrepresent Hulkbuster. So they literally sent back the thing with the draw over with red circles around things saying you've got to change that. So that would have been a lot trickier if Colin had made it all manually. And obviously he had to have drawn sketches to cut it with a plasma cutter unless he wanted to do it with an angle grinder. So it's quite handy having the CAD as well to actually do that, get the approval and get it all done in time and have a machine cut the parts. So yeah, it was a good collaboration, I think. Colin said he doesn't really want to do collaborations for the sake of collaborations. They've got to be for a reason, like there's some skills that he hasn't got. So that was quite a good one. And what would, I can't think of a video my subscribers would like more than building Hulkbuster with Colin Furze. Couldn't really put better words together. So yeah, altogether pretty cool. So I am, however, obviously, oh yeah. So could the two Hulkbusters battle each other? I think the new one would win, and it would probably kill me. I actually still have the old Hulkbuster, and the original plan was it was going to go to Blades Toys' new office and stand behind reception, which was my 2-day-a-week day job. And the two things that happened with that were Blades Toys didn't get a new office, and also I don't work there anymore. I've actually left Blades Toys, and I'm now almost still a full-time YouTuber, but I still actually do have a 2-day-a-week day job that I've just started doing for a startup. So I'm doing some work for them. It's a new distributed manufacturing business, but with more focus on a product rather than on printing what anyone wants, like 3D hubs. It hasn't launched yet. It probably won't launch till the end of the year. I'm doing some initial design work and helping out with the web design guys with trying to do building slicers into a web service and things. Haven't really got any links because there's a website, but there's nothing on it, and there's no social media. So more to follow on that, and I'll be presumably it'll all be successful, and at least something will launch. And at that point, I'll be making videos about it. But for now, it's working from home, doing 2 days a week, which is kind of cool because I can run my 3D prints at the same time and all that stuff. So it should make me more efficient. So I've still got the old Hulkbuster. It's in a storage unit. I need to get rid of it really because I don't think now we've done this Hulkbuster, the old one isn't really going to come out again. So if anyone wants a Hulkbuster and they can collect it and take it away, it's in Southampton in England. Let me know and you can have it. I don't recommend using it as a costume because there's lots of screws sticking through to the inside. And also, when we demoed it the last time at DEF CON, which was the year before last now, we couldn't stand it back up again after because the knees went wobbly where it's supposed to lock. But it'd be fine as a static prop if you screwed wood in the back. It's 8 feet tall, so you need high ceilings. But yes, it's free. There we go. Yes, I did consider crushing it with the new Hulkbuster, but I thought it would be the same as when I crushed an Iron Man helmet in hydraulic jaws, which was wildly unpopular. So I'm not doing that. That could have been my part 3, but anyway, Hulkbuster's fight. There we go. The main thing about doing Hulkbuster, so obviously we do the build, then you've kind of got 6 to 8 weeks blocked out. So I end up bringing the Hoverbike project forward, the Batsuit project forward to make those Tuesday videos to fill up the time where I was doing whatever else for Hulkbuster, because those 3 videos go out at the end. The plan would have been that those 3 videos go out. So that's what we did with Star Wars, was we did the reveal first, then we did the build videos. So I had 2 or 3 weeks while those videos were going out to go back to make my regular content. With Hulkbuster, we did it the other way round, and we really got pushed to the end. So we put out the first build video before we'd finished and before we'd shot the reveal. So I ended up dealing with those videos and the edits and all that stuff and the approvals. Even on the final video, I didn't edit. We still had to go backwards and forwards and get bits of footage and, all the stuff. And there were several versions. There was one for eBay and there's one for me. And there was supposed to be one for Colin that he didn't use. So there's a lot of toing and froing. So I really didn't get any time back till the last episode was going out, and hence I didn't actually have any time to get back to my regular content, which is why I've then had to put out whatever it was that I put out, which was, I can't even remember, the CNC video, of course, which I did actually make, but it didn't take too long. It was 2 days. And then obviously next week is going to be the Hoverbike, and the week after's Batsuit. And now basically I've just finished the Batsuit making. I've got to do the video. So that means from tomorrow I can start back on regular content, basically, which is Robot X is coming back for at least 1 episode and finishing the CNC stuff to get the next part of that done and get that up and running, which I've got to learn. So I really didn't get any time back. It just blocked me out for 8 weeks, and that was it, or whatever it was. So yeah, I wouldn't have ideally put Hoverbike and Batsuit out every other week or whatever it was for some of those weeks. But I kind of had to because I was too busy. So they would have been Friday videos. So there we go. But that's just the way it's worked out. Obviously, there's only one of me. So yeah, but the strategy going on for the channel is to try and polish off some of those projects. There are going to be more bat projects, but the Batsuit's got one more after legs, which will be for the cowl and tidying up, and then basically it won't come back till I do the Batsuit, which will be a bit further, the bat board, and that'll be further down the line. So we're going to be doing serious robots, which I think is what a lot of people want to hear. So yes, Robot X is coming back. I'm going to be making foot pressure sensors, which look like this, which are magnets and Hall effect sensors and springs, and there'll be one of these on the front and back of each foot, so I can measure the 4 corners. So I'll actually be starting work on that tomorrow. So I've already printed the others, but I haven't trimmed them and assembled them. And then the plan is to make that work as best I can in the fewest episodes possible. I'm going to strip all the Spider-Man stuff off and just leave the actual robot. And then I'm going to make it open source. So I'm going to upload all the CAD and code to GitHub. And that's pretty much polishing that off for now. I don't think I can make it work very well for reasons. And the reasons are that basically the way I designed it was building it as I went along. And, you know, the code is basically some PID controllers and reading IMUs and adding some numbers on here and here to try and balance it. And altogether, it's not really the proper way to do it. So I'm just going to say, there we go. If someone else wants it, you can do what you like with it. Then I'm going to go away, do the OpenDog project, basically learn how to do robotics properly. And then if I think I can do anything more with Robot X, I'll come back to it, but otherwise I won't. Obviously, the dog is 4 legs, but there's actually going to be planned properly with a mathematical model that should make even stability with 4 legs, you know, to take side steps if you kick it and those things. That'll be an easier one to work on, and a more in-depth proper robotics build with proper stuff. So there we go, and I'm going to talk about that shortly. But there's some questions. Do I get movie part offers? I have no, is the answer to that. I haven't been offered a part in a movie. I did get asked a funny question about could I use for a robot. Somebody wanted me to repaint Ultron as a gardening robot and change its head so it could be in a music video about robot uprising. But I'll talk more about that in a minute because that's another potential project. So there we go. OpenDog. Right, some of it's made, but not really. We're just going to quickly. So let me just quickly grab this because it's exciting. It's OpenDog's controller, which I did post a picture a while ago for patrons, and it works for what it's worth. Let's just plug it in. Actually, it probably won't do anything. So it's got 2 3-axis joysticks on. So these are joysticks, but they also rotate. So that's the main controller, which sits that way up in your hands. And you can kind of just hold with one hand, and that's for its 6 main axis, which will do different things in different modes, which you'll have this sort of menu system for. So and basically those 6 axes I'm going to describe, and they're going to be defined in a mathematical model. But for a bit more excitement, let's just have a look at some of the other parts that I've got, which are in this box and all over the place. So far, there is a Bluetooth link, and OpenDog currently looks like this Arduino Mega 2650, which is running some of the code that I've already written. It won't always be this, it might be a teensy, but for now that's fine for just doing some maths and getting the numbers out, basically. So that's why I'm using that, because I had one, and it's 5 volts. This box, with Hobby King written all over it, contains, well, let's have a look, contains stuff for OpenDog. It contains some encoders that I haven't looked at yet, which I need to test. A box containing one ODrive Robotics dual brushless motor controller, which talks to encoders and gives you very precise control over brushless hobby motors, which is what we're going to use. Lots of paper with loads of triangles drawn on. Sorry, you can't see that. Which is me working out the trigonometry for its mathematical model. Actually, I don't know if you saw the O drive now. Was that in shot? I have posted a picture of it. It might have been. I can't really tell, but there we go. Ooh. Yeah, it's not that exciting as a board to look at. I need 6 of those because it's got 12 motors. What else? I think this is more encoders, but not the right. So yes, cables for the encoders. And this one is some other encoders, which, well, okay. These are standard quadrature encoders. But the other encoders that are in here apparently have a Z index, which is better. And these are the ones that are recommended by ODrive. Okay, so that's good. So that's that. And then the rest of this box contains loads of brushless motors. Now I am going to steal 4 off the exosuit, but the other 8 are in here, and these are the same huge brushless motors that I used in the exosuit, which are 2 kilowatt, 149 kV, 63 mil diameter, 74 mil long brushless motors. There's going to be 12 of them. So as you can tell, this project's going to be fairly substantial. I didn't want to make a little, you know, desktop IBO size thing with servos in it. I really wanted to get control over everything and have some power. So 12 of those, 2 kilowatts each. They're only going to run on half the voltage, so they'll only do about 1 kilowatt each. I could have used smaller motors, but they've got loads of torque because they're really big. And obviously the exosuit's bonkers, so it's the same. And then, let me just find the rest of the things, or some of it. We'll be using, similar to the exosuit, all in, they're quite oily, but yeah, the ball screws again, so 12 of them. And then a load of extrusion and a load of CNC parts and a load of 3D printed parts. So let's just grab some. So this is a load of extrusion I've had cut to length already. So this is a C-beam, which is a C shape. So it's like loads of 2020 stuck together. So that you can see, it's about 900 mil long. That's the main body for the dog. So it's about that long, and it's going to stand about 600 mil tall. So there's some 2020s here, which make up, they're half a leg each. So yeah, let's just. It's something like this, whichever way the legs bend. Oh, I can't do that for some reason. So significantly sized. Yeah, which is about the same size as Spot Mini, I think, from Boston Dynamics. At least there's a video out about autonomous navigation for that robot, and it walks past some desks and chairs, and it seems to be about the same size. So a sort of like medium-sized dog size, which is good. Right, let's just quickly have a look at the chat again. Me leaning over. And I'll talk more about that because some unrelated questions. How come you don't do acetone welding of 3D parts? Because I use PLA and you can't acetone weld it. Well, you might be able to, but not as well. And super glue with activator works really well, so I do that. Haven't printed in ABS for ages. More Struder, you can't really print in ABS because it warps so much because the extrusions are so fat, so the shrinkage is much more. But PLA is really tough. Obviously, the skateboards are all PLA, so just resort to PLA now, really. Your projects would work for stop motion sci-fi. I guess they would, but stop motion takes a very long time, so I don't have the appetite for that. But anyway, yeah. ODrive doesn't have a holding feature. Well, it's got an encoder and you can go to a position, so I don't know what's going to happen. I need to actually power that up and test it and see if that's right or not. So it could do, I mean, it will try and get to that position, and if you then manipulate the motor, it should try and drive back like a servo because it's then the encoder's moving. So with the exosuit, even though motors don't exactly have a holding feature, I've got the pot on the joint and a feedback loop saying go to that position. And if you then try and turn it, it'll turn back again because the pot's moved. So it's just basically like a PID controller that's trying to keep on that position. So I don't know what will happen with ODrive, whether it'll automatically, I mean, you can define the PID parameters, so presumably it will if you then yank the motor. But the ball screws aren't really, you can back drive them if you put tons of pressure on them, but they're not that back drivable either. So that's why I've used ball screws. And also the zero backlash, and they're only £20 each or something, whereas a planetary gearbox would have been like £100 or something like the one I used in BB9E, so, and just as heavy or heavier. So we'll see how that goes. I do need one of the episodes for OpenDog, the first one, will be talking about all of this, working the maths out and testing the ODrive and deciding whether to do that or whether to use VESC and my own feedback with my own encoders or whatever. So yeah, that's that. Yes, do dogs like silicon? I don't know. Silicon snacks? I think they eat nuts and bolts like other robots. Yeah, the ball screws will help. Yeah, so reverse engineering Boston Dynamics, it's not going to be as good as that. It's going to be, there's, for reasons I'll discuss shortly, which is that they don't do it the traditional way that you do robots. They've got their own special stuff that they've developed, which is why it's so dynamic. But it'll be, yeah. Why not? It's open. I'm going to make it open source. The plan is every video I publish the CAD and code on that video on GitHub. So basically, you can see it's open source from the start, and anyone can then take it and do anything with it at any point. Yeah, it is a big dog. It's going to be significant and heavy. I think Spot Mini weighs 30 kilograms. I think this is going to be about the same. The biggest weight is the motors and the ball screws. The extrusion is heavier. I mean, you think, oh, this extrusion's not very heavy. That C-beam weighs quite a lot, actually. But nothing compared to the motors and steel ball screws. So that's, yeah. Marco Reps channel. I have watched some videos about ODrive, but I haven't. There's also that Geared Down for Everything channel or whatever it's called. They've got one as well. So, yeah. Robots do eat money. This one does. I mean, obviously, it's the video series will be billed to patrons, but I've had to buy all the stuff already to make the video. So the good thing about doing Hulkbuster with eBay and those big deals is they pay quite well. So obviously, some of that money's got reinvested into high-end projects for the channel. So yeah, I don't know how popular it will be on YouTube, but obviously we'll see. I'm hoping that I can publicize it on websites like Hackaday and stuff like that from the beginning because it is open source. So you may have seen OpenCat, which apparently was going to be open source, and he called it OpenCat, but it isn't open source because he hasn't published it. So there's a GitHub, but it's got nothing on it. And he's now talking about making injection molded kits and selling them rather than just publishing it and saying, oh, you have to print precise parts to make it work. So, you know, the average person can't make it or something. But that's not the point in open source. Yes, I just answered that question in the chat. Yes, so it isn't actually, OpenCat isn't open source yet. If it is, we don't know. So that's what's happening there. So yes, let's just quickly look at the CAD actually. I'm just going to share my screen and hopefully not cut everyone off like I did once. Application window, right, Fusion. Yes, here it is. Hopefully you can see. Let me just get the chat. Hopefully you can see the CAD that I've got here, which is the OpenDog CAD. And I did post a picture or two. If anyone wants it, you can have it now, but I don't recommend building it because I haven't obviously worked out all the details. But basically, you can see there's 2 motors on each leg, which is 8. Then there's another one that doesn't exist yet, which will tip the leg this way as well. And those are going to live right up in here, pushing these things against something I haven't designed yet. So obviously there's my big C-beam through the middle, and then these plates here are going to be CNC'd on the CNC machine in aluminium plate, which is 10 mil thick. It might be thinner than that. And I was thinking about that weight adding up, as well as these blue plates. And then I just thought that's nothing compared to the motors and the ball screws. So obviously each leg has, you know, these motors that actually can simulate the ball screw there, driving up and down to turn the leg there. So that's one. Same arrangement with the motor with like a 3-to-1 or something reduction straight onto the ball screw. Might use 3D printed pulleys, might buy aluminium ones. We'll see. I don't think I can CNC those, but we'll start with 3D prints and see how it goes. And then obviously the top of the leg does exactly the same thing with another ball screw at the back there. So we get those 3 degrees of, well, sort of 3 degrees of motion on each. The legs don't twist, so there's only 2 at the shoulder, or whatever you want to call it, the hip, and then the knee there. And obviously, unlike Robot X, which had parallelograms, so it had a bottom of the leg because it had a flat foot, there's no flat foot. So we don't need to worry about a motor in the bottom there operating the ankle. Now, I could put an ankle in so I could measure pressure on the ground, a bit like those little Robot X measuring things I just showed you. I'll probably print NinjaFlex feet, and we might put some sort of pressure sensor in there, probably made with a Hall effect sensor and a magnet. So the Boston Dynamics Spot Mini has a sort of loop foot that looks like it crushes as it treads down, and then you can just use that. So I probably need to shorten those extrusions and make a kind of circular loop on the bottom of the foot. It's possible that these rods as well that push the legs might have shock absorbers in them eventually with a pot on, so it'll be a bit like a series elastic actuator. So we'll see how that works though, and we'd have to build that into the kinematic model. So the mathematical model that actually defines all of this. So that's pretty much what I think it looks like. I haven't finished really designing it yet, and most of that, as long as the mathematical model works, some of those design details can be worked out during the series. Right, should be back. So yes, there will be a certain amount of building as I go, but the main thing I didn't do with Robot X was make sure that I could calculate a mathematical model, whereas I am doing that with this. So I'm doing a lot of planning beforehand, doing the code, making the controller, making the other Arduino with the code on, checking the code and the maths works against the CAD by measuring it, then building it rather than building it and then saying, oh, how the hell am I going to control that? So yeah, that's what's going on there. So let's, good, CAD is working. Yes, the wrist, as I said, might be a pressure wrist, but that's all it'll do, and it'll just go down flat when it treads, but it might be something else, but not for now. Gear reduction in the head section of a drill. So they were planetary gearboxes straight driving the ball screws, so I could do that, but then I have to buy planetary gearboxes and couple them all together, and that makes the actuator really long as well. Whereas folding it back on itself, so the motor sits, like in the exosuit, the motor sits here and the ball screw sits here, so they're compact and next to each other with a belt drive. And obviously that's the fast side. Most of the gear reduction is in the ball screw, so the belts don't really skip if you get them tensioned okay. Even when they weren't tensioned okay, they still worked on those wobbly plastic brackets. So I think that's going to be fine, and it makes it much more compact. So could I use plywood for the cross pieces? Yes, I could use. I could do all of those things. I still think the weight of the motors and everything is going to, for a 30-kilogram robot, I want it to be pretty rigid. So I'd rather just cut, even if it were 10mm aluminium plate, that, you know, it's going to be rigid and it's got to be ready to hold itself and not twist. And so the C-beam is incredibly rigid. I don't know what you'd have to test twisting it, but it doesn't twist really, for the sake of this, you know, for this example. So it's, I think that's going to be rigid, and for the weight saving in plywood, which will bend, there's probably not much point. I did consider making it all out of CNC plywood, but you know, it's open source, so if you want to make your own with plywood, then you know you can, or whatever you want to do. So that's the whole point. So yeah, there'll be some extra frame kind of coming up with some extra bits of extrusion, I think. So they'll be sort of skeletonized, but that's just in case there is any twist, and also to put electronics on and make a shell around it so it doesn't get smashed up if it falls over and things like that. So yeah. So the main thing that I've done when I was waving this controller around was basically working out the inverse kinematic model. So basically, kinematics, is the study of motion, of course, and the kinematic model means that I can say, for instance, here's my arm, right, I'll put it over here, here's the end point. So what's the angle of my wrist, the angle of my elbow, and the angle of my shoulder And using trigonometry, I can work out where my endpoint is. But inverse kinematics is what we need in this case, is to say, well, actually, we know where we want to put the endpoint. Now calculate what all of these angles do. And it's quite important that we can work that back. So what I actually want to be able to do with this is move the leg endpoints in straight lines. So to move my finger straight up, of course, involves moving several joints at once to move that in a straight line as best I can straight up. And to move it forward, of course, involves moving some more. So if we take a square here, which I'm trying to draw in the air, but I'm not doing very well, and we plotted x, y on it, what we should be able to do is move the endpoint to any x, y we said, and recalculate where those joints should be. Now, of course, there's more than one solution, because I can go like this. So we have to be careful to avoid that situation. With the dog, it's slightly simpler because the legs are just a triangle. There's two triangles. So in fact, if I just quickly flick back to the CAD there, I've made it easier on myself. Oops, that's not it. Where are we? Yes, I've made it easier on myself, you'll notice, by putting the ball screw here in line with this joint, and all these points are in the middle, so that makes a perfect triangle, so it's very easy to work out. It's the same with the top as well. I've offset this joint, so it's not in line with this big piece. It's in line with that ball screw again. And that's a perfect triangle, so it makes it much easier to work out. If I want to move that leg straight, I've got to move this a bit that way, and then I've got to straighten the leg slightly to get it to, move in a straight line. So, and obviously the same in all directions. So basically I've made the design easy on myself to calculate that inverse model by working the trigonometry back to get to where I need to be. Which is what I didn't do with Robot X. And what I've done with Robot X is there's loads of old offsets and all sorts of things that make it very hard. There's too many unknowns and you can't quite calculate it back. So coming back to the controller, the two 3-axis joysticks, let me just get the chat back. Basically, for the 6-axis, the robot will be able to move in using that kinematic model. So on the right-hand side, we'll have translation. So basically turning it will make it shorten its legs and go up and down, and pushing it forward and backwards will make it move in a straight line. So in doing so, in order for it to just transition sideways, it has to sort of make that leg longer and do this sort of thing. And then that involves moving all of those joints, working out, keeping the height from the ground constant and moving in a flat plane, or changing the angle, the height from the ground, by turning this knob that will make it crouch down and then move in a straight line. But obviously, it has to use all those same numbers work back in, so that it's one, continuously calculated thing that works all those joints back. And then once we've done that, and we can move the legs in X, Y, and Z relative to the body, the other one will be the pannier and tilt. So that will cause it to tilt all round and rotate by moving its legs like this and actually rotating its body. And because they're all using the same numbers, the required height from the ground is set by this, but then that's worked back into the other maths. You should be able to simultaneously wiggle all of these round, and it should be able to, do that thing like Spot Mini does in the Boston Dynamics video, where it wiggles all around, and its feet stay on the ground, and it can move in 6-axis. And they've also got that weird head arm on it, and there's a thing where that head then stays still no matter what the robot does, and that's because they know what the pose of the body is relative to the ground. So it's just a case of working that out again for the head, using where now your origin is, and doing the same thing for that to keep that in the right place. So it's actually relatively simple, and most of it's just high school trigonometry, or calculus as you call it in the US. We just do it as, when you're doing your GCSEs at secondary school. It's just trigonometry, and there's loads of websites aimed at secondary education about solving triangles. Solving triangles is fun, and things like that, which is basically where I've gone to work out whether it's arctan or arccos or whatever it is I need to do to solve the triangles, because I can't remember because it was more than 20 years ago. All right, let's look at some questions. There aren't too many. Good. Air ram drive. It might be, but the problem with air is I need to have compressed air. So that means having it attached to a compressor or carrying the air, which is a a big cylinder which weighs something, and then it runs out. Also, it's hard to position those actuators. I'm aware of air muscles and things, and you can do some accurate positioning, but you generally need a push and a pull if you're using air muscles, and if you're using a cylinder, then it's dual action. Then you need proportional valves so you can control the position accurately, and those valves weigh something. Yeah, you could have a compressor on board which would probably be electric, but then you might as well just use electric motors, unless you're making like the bigger big dog robots, like the actual big dog, and the others are hydraulic. They're electric. They've got either an engine on in the case of big dog, or the others have got an electric pump powering hydraulics, with all the hydraulics with proportional valves. Like the Mantis robot, if you have a look at the Mantis robot in my channel, which was built by Matt Denson, which is a hexapod where you can ride in. Proper proportional valves, hydraulic control, microcontroller driven PID controllers, all controlled by a Linux computer. Only his has got an engine. Big Dog has got an engine, and the smaller ones have got an electric, probably a brushless motor that drives the hydraulic pump. But I'm not going down that route because it's far too complicated. Hydraulics are complicated. The thing we did with Hulkbuster wasn't really proper hydraulics. It was just a motor and some on-off valves and some relays switching them. We had no way of controlling the speed. We looked into it, but the motor drew over 100 amps at 12 volts. So controlling it was going to be problematic. So yeah, electric it is for now. Motion link in Fusion 360. Yes, there are. The motion link in the assembly is used for that example. So the slider slides. Well, in fact, is it? No, I don't think it is actually. No, it's not. It's just an as-built link and everything works. But yeah, you can use motion link, so you can wind a handle and something will slide, and you can make the thing so it turns however many times, so you can effectively simulate a ball screw. So yes, I have done, but not in that example. It takes a bit of fiddling, but yeah. Right. Will you make Hulkbuster walk after the dog? Right. So another project with Colin Furze might be hydraulic walking legs, but it's going to be a complete rebuild. As I say, those legs can't be lifted by humans. The problem with walking robots is they really want the mass in the body and very light legs, so they could easily pick up one leg. And even if they sort of statically shift weight onto the other foot, if the other foot's really heavy, they have to lean over really far, and those legs are just far too heavy. So we'd have to bring the pumps into the body. We'd also need ankles that can tilt and hold themselves, and hips as well, when the joints just don't exist. At least the hips do, but they're passive, so they'd need another 4 cylinders. It's basically a different project with probably some smaller, lighter cylinders, somehow proportionally controlling it all. A different pump system in the body, we don't know yet. But yeah, we'd like to make a walking robot that can carry a person. That's where we started with Hulkbuster, and quickly realised that was going to be hard. Yes. So yeah, so that's OpenDog, and I'm going to be trying to get the Robot X out of the way and published, because people have asked about what's happening with that. It kind of never really worked properly, and I don't know if I'll be able to make it work properly, but I'm going to give it away. Yeah, more CNC, that's ongoing. I'm currently building the box for the CNC machine in the new workshop space, which we should talk about next, I think. Then I've got a couple of other things. Yeah, so the new workshop space isn't really a workshop. I don't have space for a workshop, so it's a set. It's in my lounge. Basically, I put some studding up against the walls, blocked out a window, put loads of board up, and built a set. My lounges are far too long anyway, so I've just stolen an end of it, and it's in there, where the droids used to live. Basically, in that corner where the droids were. And that's where the CNC machine is. But I didn't want people to shout at the screen, because there's a CNC machine in my lounge. It's not really the right place for it. So that's why there's a set that looks like a workshop. But I can't really make a mess in there because it's my lounge. So yeah, so there's a box being built at the moment for the CNC machine, which I can show you a picture of, actually, if we just let's just find where on earth I put that. Right, here it is. My hard drive's gone to sleep. I'll show you in a minute. Yeah, so I'm basically building a box to keep the dust in and some of the noise in, so my neighbours don't shout at me too much. Most of the time I'll be cutting in the day, So I think that's going to be okay. Let's just share this application. There we go. Yes, here it is. So that's what's currently being built. I've been doing this today. I was going to take the camera down the live stream, but I can't because it's attached to a cable to my desktop and I'm on the top floor. Yeah, so that's my CNC enclosure. So you can see in the background, there's some foam, which is sort of soundproofing foam that should deaden the sound a bit. Even just spinning the spindle up with the, obviously with the door on, does make a massive difference. I still haven't cut anything. So, but yeah, you can see the white ceiling. That's my normal domestic lounge ceiling. So yeah, which I try to keep out of shot. The thing's made of twin wall polycarbonate for conservatory roofs, which isn't really soundproof, but it still is better than nothing. And I'm hoping the foam in the background will sort of deaden any reverberations anyway. But yeah, it does make a significant difference of just the machine as it is. So that's what's going on there. And so learning to weld is a bit of a challenging one. I don't really want to MIG because it's sparky and messy. I'd have to do it on that bench, I think. So I was thinking about rod TIG welding because it's clean, which is one of the motivations there for doing it. So, but that's still to happen, really. I do actually have a dining table, which is in a kitchen diner, so I don't actually eat my dinner in there. And in fact, I don't go in there much because I don't really sit down and watch telly that often. So, you know, it's just a really big room that is pretty pointless. The house is a very funny layout. So, yeah, it's air cooled. Yeah, metal chips. Yeah, maybe. Well, metal chips could light it on fire. I hadn't thought of that actually, but it's flame retardant foam. It's a proper foam from a proper foam supplier. So hopefully it won't burn. I'm only cutting, hopefully if I cut aluminium at the right speed, it'll make a nice swarf and it won't chuck chips off, but that's something I still need to learn. So, yeah, TIG for smaller stuff. So Colin does a lot of TIG. All of Hulkbuster was TIG welded, all of that frame, all of those big pieces of steel. But yeah, you can do aluminium as well, which is quite useful if it's clean, apparently. So I've never tried it. I've done brazing and a lot of soldering, obviously. I kind of prefer that idea of having the rod in the other hand rather than having a wire feed on a trigger. So that's kind of what motivates me, that it's cleaner and nicer. And when you look at nice pictures of like welds, they're probably TIG welded where you can, you know, make the nice zigzag and all that. So that's what I want to do. I want to make visually pleasing videos as well. And that's why the CNC box has got loads of clear panels so I can get light in. I can stand a big softbox, you know, light right next to it to get light through there and film inside it with a GoPro, or just take the side off and put a DSLR in. So I can actually get some quite good quality, nice videos of aluminium being cut and all sorts of nice things. And I want to do the same with welding somehow. So at least the things not being a splattery mess like a MIG weld. So yeah, that's what's going on there. So yeah, okay. I still need to learn a lot about CNC. I know a couple of people who've done it, and I'm hoping to get support from Vectric, who are giving me some software. I might go and visit them to learn CNC. And CNC router parts also, they're in the US, but they'll give me support. So yeah, I still need to know lots of things. I could probably do with coolants. Apparently you can get an oil mist coolant, because there's no tray to catch liquid coolant, which just sticks to the part, or you can spray or brush it on or whatever. So I don't know. I still need to investigate. So yeah. Good. It looks like some people know about CNCing. I don't know. Yeah, I'm still learning, but I'll work it out, and I'm going to take my time with it because, you know, I'll do some wood to start with. That seems easy. Yes, but I've got aluminium bit, end router bits, and a ball bit, and a taper bit as well, which came with it, which is 6 mil. So what's that? 1/4 inch ones for metal. So, but yep, still a lot to learn. Good. The other thing I want to talk about, yeah, was the hoverbike, I guess. So the hoverbike project turned out kind of okay in the end. It's kind of playable. They haven't quite finished, and they probably are going to finish. They actually scored 81% as a team. And so the hoverbike will be living at the Portsmouth University. Next year's final year degree students will be doing a project with it again. I might make a video about it. We'll see how it goes. But obviously we've seen it, so there's only so much you can do. The game could have been faster moving, and maybe if it were faster moving and you went in a straight line and there were like basic blocks like in Tron, the original movie, and simple things you had to shoot, it might have been more of a fun game, because it's actually quite tricky to steer on the track, which is why you have to go slow, and then it's not quite as fast moving as speeder bikes should be. So, you know, but that was like, I had to give them free rein really to score all the units they needed for their degree. So they had to do character design, they had to do environment design, and so on, and all those things. So we couldn't really just have blocks you shoot in an alleyway, because the other guys wouldn't have been able to score all the points they needed. However, yes, I'm probably not going to do any more headset VR projects, because it's really unengaging for the YouTube viewer, because you cannot, what's in VR is amazing, but you can't experience it watching someone in VR on YouTube with a 2D game view. The whole appeal of VR is that it's virtual reality, and you look around, it tracks your head really well, and everything's 3D. You just can't convey that through a YouTube video. And if someone can work out how to convey it for a YouTube video, and stream, I mean, you don't even want to stream 3D from the headset, because if your head isn't moving when the headset's moving, when the image is moving, it makes you sick. So I did some experiments where I had the camera view bound to a handset, but you could view it in a headset, and just moving the handset around and getting the 3D view in your head made you immediately sick. So there's no good even for someone to be able to look at what the person can see in 3D. They'd have to have some other way of navigating around the environment in 3D as a third-person viewer, but it'd be very hard to render all of that out once someone's already done the stream. It might work for a live stream potentially, but you'd never get the latency down. Anyway, headset VR projects aren't very popular on YouTube because it's just not the same experience. So there probably will be a student project next year, but I want to do something more like, if we do a game project, and basically I know the course leader in computer games design, which is how this all happens. Who remembers the Hyper Reality Blaster, the Lego Hyper Reality Blaster? So there's a project in my channel, if you haven't seen it, it did quite well, it was quite popular, and people thought it was good, and everyone who's seen it thinks it's clever, so that's something. But basically, it was a Lego gun. It had a screen on it, and it had an HTC Vive handset under here somewhere. So basically, this became the VR viewer, so you could point around and look into the virtual world, and when you shot things, which were Lego men, they were also a physical representation of the same Lego man, printed from the same CAD in 3D. So he was stood there. There were three of them. You could see them when you looked through here. You could see their virtual representation. And when you shot them, it shot a Lego man head, and then it knocked down the physical one in the physical world as well as the virtual one. And so, obviously, from the YouTube viewer, they could see what was going on in the physical world, that these targets were getting shot down. They could see a little inset window of the game view, which was the virtual world, and also had a GoPro mounted on here, so you could see what I see. And so that was much more engaging, because it was clever. It was like augmented reality. And also, it was just like there was no lack of clarity. There was nothing missing, because there was no 3D headset view. And the game wasn't reliant on 3D virtual reality. It was just a 2D view. So it's just like a viewfinder. So that was quite a popular project. And so I was thinking, if I do another project with students on computer game design, it should be something like that. It should be something where the computer game is okay, they've done some graphics and they've done a better version of this, and there's scenery, but then there's these physical things. And I think there should probably be something a bit more involved than that. It should be something like a robot. So what I wanted to do was fighting robots, where you've got two physical robots, maybe 4 foot tall or something, that can fight each other, that go around on wheels. And then to make them fight, you've got a gun and you shoot your opponent's robot, and wherever you shoot it, the robot tries to hit your opponent there. So that's where we started with it. And then obviously on YouTube, it's much more engaging seeing these robots fighting. And oh, by the way, it's controlled by augmented reality. Building two robots that fight each other is actually quite a lot of work. And they need to start this in September, which sort of gives me time. But I don't know if I want to do another dedicated robot project just for that. I suppose I could. It wouldn't come out till next March. Yeah. So then this other thing happened where this guy. So basically, what appeared to happen was there's a hip hop artist called Plan B. Someone contacted me saying they were making a music video for him, and they wanted this. They wanted Ultron painted like a gardening robot, and a new head, and another set of arms, and can you make it puppeteered by humans? And we want it in 7 to 10 days for this music video. And I was about to go off and do the Hulkbuster shoot, so I couldn't do it, obviously. And 7 to 10 days wasn't really long enough to make all that stuff. So it got me thinking that perhaps there's a business model in kind of having off-the-shelf generic robots ready to hire for stupid people like that who can't plan ahead, and like advertising and, you know, music videos and or dancing robots for DJs and things like that, which you could basically just build and then charge a day rate. So almost like Ultron, but only one made with high-end motors and things like the ones I'm going to use in OpenDog, and a proper sort of torso that can move all around and has got all of the degrees of freedom and stuff. So that's basically, I think, what I'd like to do. I think I'd like to make one generic all-purpose kind of robot torso that can be used for those sorts of things. Now, I did have some puppeteering on Ultron and stuff, but his joints were kind of limited, and that was a bit of a mistake in interpreting the data from the inertial measurement units I originally used. So we won't do it that way. And also those motors were tiny things that weren't very high power, so it hasn't really got much range of motion, and actually it's pretty unreliable. It looks good stood there. But yes, I think what I'd probably do is make one generic robot torso project with high-end components, probably networked in the same way as the Hulkbuster control panel with RS485 and patch lead, so you can take its arm off and put it on the table and it still works. Or you can put them together and puppeteer them, maybe with a little maquette, whatever the word is, like I did with Ultron, where you can move its arms and so someone can make them dance, or you can sync two of them together. And then we'll use that. So I'll basically vlog about who I can hire it to. Obviously, someone only gets charged a day rate. They don't get charged to build the whole thing. And also we could use it for a student project to make an augmented reality controlled human interaction stroke fighting robot stroke whatever. Or it could have loads of different purposes and it'd be open source. So that's probably a project that might come up. So hopefully we've got a robot dog and a really good robot human. So yeah, that's something I think that I want to do. But we'll start the dog, finish some other things, then we'll see. But it'll probably be ball screws and brushless motors and all that good stuff again, and kind of modular. So we could bolt different cosmetics on it, could be repainted if someone paid for it, that sort of thing, and have one sort of central control thing. So let's look at some questions. Let's put this back over here. Right, 3D printing. I haven't got any new 3D printers. I have got the Lulzbot V3 dual extruder, which is specifically designed for water-soluble support. I haven't got out of the box yet. I've been quite busy. I had it a few weeks ago, but then Hulkbuster got in the way. So yeah, I still will be doing a lot of 3D printing. A lot of the OpenDog parts will be 3D printed. So the couplings that get those plates to go on the C-beam probably will be big 3D printed Morstruder blocks because there's not too much flex in them. The bearing bushings and all that stuff, the knee joints and those other joints are probably going to be 3D printed. So it's definitely a place for 3D printing. But just the parts that have to be really rigid are going to be aluminium cut on the machine. So that's what's happening there. Yeah, fighting ability of the robots. Yeah, I was going to. So I did actually do a fighting robot torso, and it used foot pumps in reverse, which were pneumatic. Whether it fights a human or not is another matter, but it would involve a lot of padding. I think the last conversation I had with Portsmouth Uni was if it was going to fight a human, everyone would have to wear like taekwondo, whatever, padded gear and only have foam sticks, and the robot only has a foam stick and a shield. But we're not sure how well that would work out. So then the foam stick the human had would have a Vive tracker on it, or it'd be on their hand. So the robot knew where the person was and where they were hitting, and so it could defend. And then the computer game aspect would be basically the gameplay strategy as if it were an arcade game with two characters fighting, but they'd be real and the data would just come from the Vive tracker. But whether we do that or not, I don't know. So we'll see. If robots wanted to dance, what will they do? Well, they do whatever a human operator made them do by moving their arms, like going like this with their arms on sticks and going, and it would make the robot dance, and someone else might have to operate the head, or it could follow the arms or whatever. But yeah, you could do anything. I don't think I'd program that part. Yeah, I don't. The thing is with having people are fighting a rope. There's health and safety. The whole hover bike was bad enough as it was, which is why it's made of massive bits of steel because anyone could get on it. So yeah, we'd have to see. It might be more of like a human interaction thing, but we'll see how that goes. So that's pretty much where we're heading, is towards some serious robots, I think. And I'd still like to get, obviously, Bat is a theme. There'll be a Bat theme going on for a bit. Get that Bat board. I want to ride the Bat board dressed as Batman. That's got to happen. And I want to make a drone as well, a Bat drone, and some other stuff. So that'll happen. But we need to break it up. And obviously having the robotics every 2 weeks pretty much is the way I've done it in the past. Means that there's time to order parts and plan ahead and all that stuff, because there's only one of me. So it's good to have some diversity in the channel. Yeah, good. All right, so those are all the things. And we've got to an hour. But if anyone's got any more questions, put questions in the chat and I'll answer them. Yeah. I don't think I had anything else to mention there. I think we're all good. So there we go. All right. I'll just sit here for a bit, see if there's any questions. Yep. Yeah, I should probably test the twist of this C-beam somehow by clamping it down and putting a stick on the other end and trying to twist it. But I don't think that's going to twist under the weight of one leg or two legs picking up. I think that's incredibly rigid, so I'm not sure how much it weighs. It feels like about, it maybe is 3 kilograms. It might be 2 kilograms. So a litre of water weighs a kilogram. That's why metric's good. So I'm just imagining a 2-litre bottle of water. So I think it's about 2 kilograms. The Fightbot arm design. So basically in my channel, there was a fighting robot concept. I'm going to get it. I know where it is. It's in the house. And we'll talk about that, which may or may not be the answer. Ugh. Here it is. So I think it'd probably have a wheeled base if I was to do this. If I would do a specific robot for fighting. Here it is. Right, let's just move the camera. There is a whole video on this. So yeah, I used these are foot pump cylinders with the one-way valve taken out. There's 3 of them, so it can move all around, and a lovely parallelogram. And then it punches out, and that's how it works. And it was going to be I was going to build a pair of robots that would fight each other. That's one arm, you see. And they were going to be 6 to 8 feet tall and have big motorized wheels, and then you'd basically have some sort of controller. I don't know, that you get, like, the public will be able to have a go and they'd be able to make them fight. But I don't. Yeah, I mean, that's a project I'd quite like to do. But as I said, I don't know if I want to build another robot just for this student project or not, or whether we should just make the generic torso and then just make sure it's strong enough. Or we could have different arms or something. I don't know, on a base, obviously. So yeah. Good. An arm with total freedom, so a person could learn to control it like your control. Yeah, so I mean, it would have, as I say, a little version you can move. So that of a little, like, version of the person. In fact, I don't know where it's gone. I did have one for Ultron that's in one of the videos somewhere. Yes, life-size Rock'em Sock'em robots. Only I don't really want to make 2 just to fight and give them to the students. So that's why we came up with having one fighting a human. But then obviously that's got its own issues. And I don't know what I'm going to do yet. I definitely haven't got time to build it now. So I think putting it off and deciding what I'm going to do with a robot torso. I mean, fighting would be good. Maybe it is a specific fighting robot or pair of robots. And maybe we don't do that for the student project. We just make it radio-controlled fighting robots. And that's another business idea, potentially, is to do fighting robot hire. As well as generic robot hire for the DJ who's got 10 days to get a gardening robot for the video, whatever it was. So we'll see. But maybe the student project is an augmented reality gameplay thing with a physical robot or something. I don't know. We still need to decide. There's got to be a gameplay aspect because it is a computer games design degree. So yeah, I'm still working that out. But what I would like to do, of course, is come sort of whatever it is have video series about starting a robotics business. So starting with a concept which is like robot hire for different purposes, and then what does the design need? How is the robot modular? So maybe it's the same robot, but then it gets different arms for fighting that are pneumatic instead of electric, and they can be configured and just plugged in with the network cables, and then there's some controller on it or wireless bridge or whatever, and what the different modules are that make up these robots, and then vlog all the way through whoever hires it. So that's the thing. Yeah. Rock'em Sock'em was pretty basic. I mean, there was a TV series with fighting robots, which sort of walked, but then they had these T-bars on the back to give them stability. I'm not sure how popular that was though, but it was almost like Robot Wars, but the robot was always the same because people didn't build them. It wasn't that amazing because it was always the same 2 or 3 robots fighting. But I guess that's different to a public interaction thing. If you went to a Comic-Con and you could have a go on these fighting robots, and someone just said, like, here's the handset. Yeah, just push forward and that punches, and that's the other arm. And then, I don't know, you tilt it or something to steer the robot round, and it's fun. Then maybe people will pay to have a go on that. So, yeah. Yeah, don't bother with the students. I could not bother with the students. I mean, they've got the hover bike anyway. We'll have to see. I'd like to do something where someone else does the high-level programming for the game. But ultimately, I don't really want to just make a game. So, yeah, as I say, no more VR for VR's sake. It'll be something else that has a gameplay strategy, and that's why fighting robots is quite good, or fighting a person, because they can do what would be the computer game artificial intelligence, but it's brought out into the physical world that makes it more engaging for people to watch. So there we go. We'll see. And if I can make a generic robot that's open source, then it's the same thing anyway. It's the same design, so then it's not so bad. And the university's actually got resources to make stuff, so they could potentially just build the same design, and then I just get some extra videos of what they did with it. But we'll see. We'll see what happens. So yes, there we go. Yeah, there is unfortunately only one of me, and so there's loads of things I'd like to do. And I guess that's why having machines make the parts is good. Without those 3D printers, I couldn't get the videos done every week, and hopefully the CNC will help. There are some projects I want to do with giant wooden gears. Some crazy go-kart ideas, but that's a low priority at the moment. I left the toy company because basically there are a few reasons. One, I had this opportunity for this startup, which is quite exciting, and also the toy company. I did the giant drone racer for them, but I didn't really have that many challenges. It was mostly we started talking about doing educational toys and things like that, but we ended up not really doing any. So I ended up with just designing plastic cars and things in the end, and simple, stuff. So different bodies for drones for licenses and things like that. So yeah, didn't really, at least they didn't invest in developing tech toys, which is where I started and why they took me on. So that's really it. And now the design work I'm doing for the new company is stuff more like a 3D printed thing with some electronics in that can be made by people with 3D printers, distributed manufacturing. Yeah, more details to follow on that. It's a bit more exciting. There's also some actually running the business to do as well, dealing with getting the service up and running and 3D printing integrated into it and all those good things, which is my expertise. And they actually want me to vlog along with the business when it gets up and running, and talk about it and talk about the projects on there. So that's basically doing more YouTube for me, other than someone pays me a permanent wage. So essentially, it's all the route to becoming a full-time YouTuber. So that's really the explanation on that. So there we go. All right. yeah, that's it. If anyone's got any more questions, feel free to just post or message me or post them on the Patreon wall, or if you've got access to the subreddit, put them in there. If you haven't got access, you can get access. I just need a reddit.com username. The intention of that was it was a forum for patrons. It's also a permanent reference for the digital downloads, because there's nowhere on Patreon where you get access to the page. Then you can. There's nowhere to just put like permanent links, like here are your rewards, here are the downloads. So that's why I started the subreddit, because it's got a pinned post at the top with those things in. It does mean giving people access to that as well, but until Patreon has some sort of proper content management system, there's not really an easier way of keeping a pinned thing that says here are the things. The post will just disappear down the wall. So there we go. How realistic is Iron Man? Iron Man 1. I mean, there is a guy who can fly with rockets called Richard Browning, and there's that other flyboard thing that the guy's done, so that you could have a suit with rockets in that you could fly on. It'd be bulkier, but yeah, you could do that. I built an exosuit, and that's everything, isn't it? But yeah, there's some military exosuits. Everything's bigger. It could be done, but everything's bigger, I think, is the answer. And whether it's as agile and you could move all your joints and all that. But yeah, most of it's possible, I suppose. Hulkbuster that carries a person. There are some robots that carry people. That's been done. Whether it would be any good at fighting anything, it can't. I mean, the agility jumping around New York fighting the Hulk probably isn't possible. But you know, I suppose most of it's possible with today's technology, but it's just going to look bigger. So there we go. That's the answer to that. All right, I think that's the end. So thanks for watching, and yep, next week's video is coming up in a few days, hopefully, which is the Batsuit. So there we go. And I'm, as I say, working on the CNC video. That'll be a Friday video, probably coming up somewhere. All right, the end. Thank you very much.